Hello, I'm David Soward. I'm also the maths leader at Woodsetts Primary School. On our website you will find some videos that we've made with the children to show you our calculation policy. So I just want to explain how our calculation policy works. Calculation policy is split into the 4 operations of addition, subtraction, multiplication and division. Each operation is separated into different stages, starting at stage 1 and working down to stage 6. Okay, each operation is separated into different stages: stage 1, stage 2, stage 3, stage 4, stage 5, stage 6. Obviously children come into school at foundation and will be working at a level that's appropriate to them. Now what's really important with these stages is the stage 1 does not mean year 1. Stage 2 does not mean year 2. Children, it's important, it's critical that they work through these stages. The reason for that is that it helps their understanding of number and of how to calculate mentally. So as an example, the written standard method, which is the method that your parents, your grandparents or my parents often refer to, when you often get people saying, why don't they do it like they used to do in my day, it's much more straightforward and it's easier and simpler and less prone for making mistakes. The reason why we don't go straight to that and we go through these stages is because these stages help children calculate mentally. So if you did a problem in your head without writing it down, you would need these skills and these processes to be able to get to that. So what's really important is if you're supporting your child at home using these videos, that you don't go straight to the last stage just because you think your child is very able in maths. Okay, so we often get parents asking us how you can support your child at home, and the most important thing is that you are doing the same method that we do at school. So to do this, we've decided we'll make some videos, and you'll be able to see these on the website, and you'll be able to click. Your teacher will be putting what stage child's working at, if they're doing home learning, and then you'll be able to click on that stage and see a child model the process. As well as that, there's also going to be what we call the stars to success linked to that stage, that are written instructions, step-by-step instructions to show you how your child goes through the process in order to get the answer correct. And in addition to that, our aim is to put on a list of questions and the answers so that you can do some additional practice. Obviously this is all work in progress and we'll improve it, so there may be a few glitches at first, but that's the vision. Okay, so in each classroom from year 2 to year 6, teachers have a calculation board, and they'll have these posters are displayed in each classroom. Year 1 have got slightly more child friendly for the lower age child in their class. And we've got the 4 operations here that we use in all calculations. So if you're calculating a maths question, you need to use one of the operations. So the operations are obviously addition, division, subtraction and multiplication. Addition and subtraction are linked inversely. Division and multiplication are linked inversely. i.e., if I want to do subtraction, I could use an addition to work it out. For instance, the shopkeeper method of counting on to find change is a subtraction question, but I could use addition. What's really important, and what we teach children in each class, is the language involved with each operation. For example, we've all heard people say, let's do a sums. That actually is not the correct way to speak, because the word sum links to addition. If you were doing 4 take away 3, which is a subtraction, that is not a sum. The sum links to addition. So please, if you can bear that in mind, if you are doing your home learning, we don't say let's do our sums, we are using the sum. Let's go specifically for each operation though. So addition, together, more, plus, total, add, sum, and an increase. As the children progress through school, particularly at Key Stage 2, their success in maths is linked to their ability to be able to read a question and work out what sort of operation is needed. And often the question will involve one of these key words. For example, a question might say, what is the total of 12 and 36, without using the addition symbol. The children need to know that that total means the amount altogether. We go on to subtraction. Difference between, if we're trying to work out 65 take away 37, we're in effect trying to work out the numbers that are the difference between those two numbers. So we've got decrease. Can you decrease 37 by 12? Take 12 from 37. Can you take away 12 from 37? Can we reduce 37 by 12? How many fewer than 37 is 12? 37 minus 12. Now we've got the division operation. We share, so young children will start down in foundation with a pile of cubes or even a pile of fruit. Can you share? Can you share at home? Some sweets between you and your friends. Is 64 divisible by 8? Can we divide 64 by 8? How many groups of 8 are there in 64? Can we divide 8 into 64? Can we share equally 8 into 64? And then we have the last operation, multiplication, the inverse of division. So speaking personally, when I was at school I always found division difficult, but then I realise now that I can work a division out by using multiples, using multiplication. So if I want to know how many 8s there are in 64, I count in multiples of 8. Question that comes up often in Key Stage 2 SAT papers is the product of. What is the product of 8 and 6? Which effectively means what is 8 times by 6? So we've got groups of, obviously times tables. We're all learning our times tables and we use the Percy Parker CD where children sing the songs. Times tables are all multiples, lots of the same number. Multiplication in effect is just repeated addition. It's a quick way of doing addition. We've got lots of and times. So that key word there, product. What is the product of 8 and 6? So obviously this is a 100 grid, and I'm sure you could find a 100 grid at the Early Learning Centre, and I would really recommend that, particularly for Key Stage 1 children that are learning about number, that you would invest in one of these and put it in your child's room where they can look at it and practice. At a young age, it's important that children understand the value of number, and we do a lot of work on place value and number bonds at Foundation and Key Stage 1. So obviously we've got our unit numbers, our ones, going along there, and then we know on the 100 grid that when we go down the columns, the numbers increase by multiples of 10. They're going up in 10. So what we would asking sometimes is, if 55 is there, can you predict that number there? What's happening to it? What's happened to the 10s? What's happening to the 1s? So 1s are increasing that way, numbers are increasing by multiples of 10s going that way. So even just counting, can you count with your child? You get a marker pen or stickers or something, can you get your child to count in multiples of 2? Can you get your child to count in multiples of 5? Can you get your child to recognise what's happening to those numbers so that they can inform themselves next time they do it independently at school? And then we can use the 100 grid to do multiples of any number for our times tables practice. We can use it for counting on. What's 12 add 6? Count forward 6 more to find the answer. Or even back when we're doing subtraction, 18 take away 6. To find the answer there. Okay, so 100 grid is a really worthwhile investment. If you can't find one, then we'll happily make a laminate one for you to take out. Okay, this is obviously a times table poster, and again these are widely available. You can find them in Tesco's. Hopefully this guy doesn't look like me, but at Key Stage 2, children learn a times table each month. We're currently in March and we're learning the 7 times table. In Year 2s, incidentally, in April, they're going to start learning their times tables. We've left the 2 5s and 10s till the end of the year, so those Year 2 children are more confident and they're going to join us learning their times tables. Times table, the knowledge of times tables are the essence of a good mathematician. Something that can calculate quickly to solve a question and solve a problem is absolutely critical. So we are overlearning times tables. We do one each month. We use a piece of software called Percy Parker where the children sing. Try and remember that way. Counting multiples of numbers in the classroom. So please support with your child doing that, counting on the way to school. Just count over and over and over again like they used to do in the olden days of education, going over and over it. So if you can have a multiplication poster at home, that would be really useful. And then if we're learning now, let's look at sevens. We're doing those at the moment. We're teaching the children to count in multiples of 7, lots of. So a good way of doing that is to use two hands, which children have got with them all the time. In my class we do the here comes Peter, here comes Paul, because we start counting on our left hands and we go round to our right. Because of the dexterity problems that children often have with their fine motor control, it's not always easy, but it makes more sense if you're using your fingers to count in multiples. So if I'm counting for multiples of 7, I'd start at 7, 14, 21, 28, 35, 42, 49, 56, 63, 70. So if I said then, what are 3 lots of 7, or 3 times 7, I think, right, I've got 3 fingers there. If I count 3 lots of 7, I count 3 fingers, and multiples of 7, I should be able to get my answer. 7, 14, 21. Now having a poster here, the child can keep looking at it and reciting them by rote over and over again. We have a bronze, silver and gold award, and generally bronze means the children can recite their times tables. 1 times 7, 7, 2 times 7, 14 independently. And then we move on to silver and gold, where we'll actually mix in some division questions and do them out of order as well. And if they're doing their division, they can work those out by using multiples of counting in 7.